Welcome, everyone. It is filling up fast, so thanks for showing up early and waiting. I'm going to give another minute or two for people to join, but then we'll get going because we got a lot to go over. But the big idea, just to give you some heads up, everyone's muted right now. So there's the Zoom chat where you're definitely encouraged to ask questions as we go, and then we're going to be curating those. Some of them I'll be trying to answer a little bit on the way, and then at the end we're going to have a good Q&A session time set aside where we'll be able to address stuff. And then, as you can see on this slide, way down here at the bottom is my contact information, and feel free to jot that down or take a screenshot, or we'll put it in the chat at the end as well. So you can definitely get a hold of me for specific questions, as well as the rest of the Oceanvolt sales team, some of which are here, and they'll be able to help out with the chats as we go. So if you're getting responses from your questions, they're not coming from me. I'm too busy talking up here. But then at the end, we'll try to address stuff more. So you don't need to hold your questions till the end. But at the end, we'll really try to address them in more detail if we're able. So it looks like we're a minute in, so let's go ahead and get started. This webinar is on the benefits of electric propulsion, with a little section on the end about things to consider as you're planning a switch to electric or designing a boat to be electric. And we'll get right into it. So just Oceanvolt in a nutshell, real quick details. If you don't know that much about Oceanvolt yet, hopefully you do, since you're following us and things. And there's going to be other times in this webinar too where I'm going to skip over kind of the really obvious answers, because I'm going to try to get into a little more detail. So when I'm talking about stuff, if there's something I'm missing that's really obvious, I'm kind of missing it because it's so obvious, hopefully. But at any rate, this is the Oceanvolt details. All over the world, lots of boats. And we're going to talk about kind of how we're able to do that, and sort of the advantages to the Oceanvolt system for, cruising, world cruising, all those types of things. I'm down here at the bottom. I'm the CEO of Oceanvolt US. And also I have a company, Captineer, that does electric propulsion installations and design. So when we're getting into the using of electric propulsion, there's a couple things that we'll touch on a little bit more later, but that really come into play for why it's actually like a better auxiliary propulsion system than a diesel inboard engine. And so I'll try to use the right nomenclature. I'm talking about electric things, I'm going to be using motor. When I'm talking about internal combustion engines, I'll be calling them engines for short, just so hopefully I'm consistent there. But basically, with an electric motor, you have full torque all the time. There's no transmission. The motor forwards and reverses itself. And so you don't have like the transmission lag. You also don't have like a stall point, a low RPM stall point. So the motor doesn't have to jump into like a 500 or 600 RPM range when you're first putting it into gear. So it gives you much finer controls down at the bottom end, and much quicker ability to change directions and start and stop. And the motor system doesn't mind being changed from forward and reverse very quickly, where that'll heat up a typical gearbox transmission. Obviously it's silent, and the thing about that is it's hard to really describe it other than it doesn't make noise. But in the actual user experience, it makes being on the boat so much more pleasant. You have obviously communication on deck, but also like I'm on my electric boat right now with an Oceanvolt servo prop on it, and it's great. My wife can be inside at the galley or vice versa, and we can be talking in and out of the companionway while we're motoring. And that's just stuff we never could have done with a diesel. And it's such an experience enhancer. It's really hard to quantify till you experience it, but it's something to really think about. And then it comes into play even more, which we'll get into, in the full boat capacity, because now, like on our boat, for example, we're on a mooring here in Miami, and sometimes it'll be really hot and we'll want to run the air conditioning, and we can just turn the AC on and run it off of the large Propulsion 48 volt battery bank. and then run the generator selectively, or let solar pick it up other times and, you know, try to use as little fuel as possible. We still will run the generator sometimes to catch up, but unlike an AC generator that we would have to run all the time with those high draws, we're just running it a little bit. And it's running in its full power zone. So it's like an hour a generator run will let us use, you know, excess power for doing the air conditioning, not for that much time, but for other things it really, you know, like, you know, an hour a gen run a week will let us do pretty much anything we want on the boat, other than air conditioning. But the motor sailing is another one that's like, it's again, it's hard to really talk about until you experience it in great detail how great it is. But if you're out sailing, and especially on light wind days when you only have like a knot or two a breeze or 3 or 4 knots, and you can get it a beam, you can take just a little bit of the electric propulsion. So at the low end, we'll talk about this a little bit later on too, but at the low end, speed is really cheap in watts. You know, 2 to 3 knots of boat speed doesn't cost very much in power. So you can put that in, and all of a sudden you have that little tiny breeze, and now you have an apparent wind loop from the boat speed, and you're going along at 4 or 5 knots with hardly any wind, perfectly flat water, absolutely no noise, and there's no sea state, so it's super pleasant. It's like our favorite way to transit from A to B now is at about 5 knots on a glassy sea. In, you know, it's fantastic, and that's really facilitated by electric. And you can do that again, like on our boat, which is a hybrid. We can motor sail, you know, at those low speeds for like 10 hours, and then just have to run the generator for like an hour and a half, and we're all caught back up again. So for long distance cruising, if you're willing to go 5 knots instead of 6 and go when the wind is light, you can really have a great time. And that's something that you just can't do in the diesel. You always have, you know, just to have that diesel running, you've ruined the experience, at least in my opinion. One of the big value propositions in electric propulsion is the ability to build completely self-sustaining vessels that have effectively infinite range. And by infinite range, I don't mean infinite range in one go, but because of the boat's ability to generate its own power through primarily hydro regeneration back through the propulsion system, using the motor as a generator, through solar, through wind, and then from shore power, which isn't, of course, infinite, that's coming off of the shore grid, but you can bring in power from those renewable sources. And if the boat is used in the proper ratio, meaning depending on the boat's performance, sailing speed, how well the boat is sailed, you know, you can figure out a ratio of, say, on a higher performance boat, 3 to 5 hours of sailing the boat at a decent speed will get you an hour, say, at 70% of the hull speed, or whatever that ratio ends up being. You know, on the lesser performing boats, the number of hours needed to sail will be higher, just because as you know, you go faster, the ability to make power is increasing exponentially. So there's some big differences in the boats and in what boats can really be self-sustaining. But in theory, as long as you're willing to accept that boat's ratio as the cruising parameters, every sailboat can be self-sustaining. It just requires power management compromises and motoring compromises. And then as you get into the higher performance stuff, those compromises can get low enough that they don't even become an issue anymore, and the boat's effectively infinite in its range. When we're talking about, you know, a lot of the power management things that we're getting into, it's important to remember a big part of what Oceanvolt is doing is kind of its engineering mission and how it's setting the systems up, is these aren't just propulsion systems. They're fully integrated, you know, power management backbones that can sustain the boat's service and hotel loads, as well as the propulsion loads, and do it in a way where everything's talking together. You can get lots of data and information about where the power is going, how it's being used, and then you can use that information to make the right decisions, to make the right power management scheme, to be able to fully self-sustain the boat. And this is an important, just, you know, as we're discussing people and as we're thinking about like what is going to be our new, you know, boats, or what are we going to do for refits, and you're starting to plan out what you want and what's going to work best for you, I always want to make sure everyone really gets this message, which is even hybrid boats can be used self-sustainably. You just by having that diesel doesn't mean you need to use it. Now, granted, having that crutch will mean sometimes you will want to use it, but I think it's important for people before they go head first into full electric, think of that hybrid as a stepping stone, almost as like training wheels, where you can put it in, you can have that diesel backup as a generator. And then as you get the boat dialed in, especially if it's a new boat that you're just getting, and as you learn to sail it better, and as you learn about the power management, where the power goes, when do you need air con on? When do you need refrigeration? How can those things be used, in the most efficient way possible? And then the generator can be used less and less until you go, okay, I don't need it anymore, but maybe I want that space and weight for more batteries or other boat systems or things like that. And then you can go off and be pure electric. And of course, some people are going to want to jump into the deep end. I'm not going to say you can't do that. You certainly can. But I just think it's important to just keep in mind that when you go pure electric, you're taking a big step into really taking responsibility for power management and for sustaining the battery bank range for when you need it. So it can't be used, willy-nilly and recklessly until you really got a good sense of what you're going to need power for and when, because you do have less range on board. It's just the power density is a fact of the situation. You can rebuild that range, but it takes time. You can't just hydrogen in an hour and have it all full again. It takes a lot of time sailing to rebuild that battery bank, or a lot of time in the sun where you're not using that power for other things. So, we need to just kind of keep realistic about this, because our biggest goal is that everyone gets a really successful system, and so part of that is really understanding kind of what we're capable of and what we're signing up for if we do pure electric versus hybrid. But I'll try not to hype on that, but it's just something I want to make sure everyone's considering as they're planning their systems. So when we start talking about like power for what you're going to need to push a boat, there's a couple things to keep in mind. If you go and you do like a direct horsepower to kilowatts ratio, you're getting the pure mathematic ratio and not really the real life scenario. So we, when people come to us with a project, we put the hull into a hull resistance calculator. And that basically looks at waterline, wetted surface, superstructure for the headwind calculations, mast height, and keel root, rudder root. So all the wetted surface stuff, waterline, of course, to get the hull speed. And then it's going to give us like a kilowatt chart that'll say at this amount of watts, you're going to have this amount of speed. And people are like a little skeptical of this because they say, oh, my current boat has a 50 horsepower motor in it. And when I do the per horsepower engine, when I do the calculations on it, I'm finding that, you're suggesting I put in something that has like half of that amount of power in direct, ratios. And the reason for that is this chart here, which is basically giving us the this, if you look at the top, the electric motor one, this is the torque and RPMs. Like I was talking about earlier, at low RPMs, you still have full torque. And then where, let's say about the middle of this chart is going to be, we don't have it on here in numbers, but it's going to be about 1,800 to 2,400 RPMs. And that's really where the motor, depending on the propeller size and pitch, what the shaft is turning at. And so you're going to find that, this diesel engine may be rated for 50 horsepower, but that's only at a really high RPM. In fact, an RPM that with that boat's speed and the ability of the propeller to walk through the water is actually like theoretically impossible. But the motor is sized for that because of stall torque. And when the engine is first put into gear, if the RPMs are too low and the displacement is too low because of the torque, if the torque is too low, it'll stall. So you have to pop it in a higher gear, and then you have to have the entire engine oversized to sustain that stall point. So you end up with a lot of extra displacement that you don't need. So that also translates to the DC to DC generators that we're using in the hybrid systems. We're able to create a lot more power in a lighter weight package, because operating as a generator, the diesel, especially as a DC generator where it's charging batteries and it doesn't need to modulate until it gets into like the float, it's basically going to be able to run right in its power band, where it will be on this red thing right up here in the top of its torque, at the top of its efficiency. Whereas in actual application, most of the engines in the marine application are running down on the left end of the red bar, where they're not as efficient. And so you're gaining efficiency, and obviously the torque profile is just huge, because that's really what's driving the boat. Horsepower is work done over time, which is again counted and rated at the ideal RPM for that engine's power band. So it's important to keep track of those numbers. So, the quick kind of rule of thumb in application, and it differs from boats and how the boats are rated. But, I usually think of about 10 kilowatts to about 25 horsepower equivalent, maybe even a little bit more in the horsepower, 25 to 30. But if you're doing just kind of what your boat needs in power, it's kind of on that range. But this isn't another important thing to remember. As the boat goes faster, your power consumption, again, this isn't perfect, this is just kind of back of the envelope math, but is going to double or a little bit more than double at each knot of speed. So if you're designing a system on a boat and you want that cruising speed to be 7 knots, if you're willing to accept 6 knots, you need half the power. And that's half the batteries, or you think, and that also goes for range too. So especially if you're doing pure electric, there's a lot of range if you go slowly, because again, as you speed up, you're not increasing your power consumption proportionally, but exponentially. And there's a point where you hit the hull speed where you get hardly any return on investment. And those are all really important concepts to keep in mind. The next one I'll go through quickly because it's pretty self-explanatory, but the diesels are so complex and we're so used to them, and we know what the stuff on them does. So they don't seem as complex as they would if someone were to just come and be shown an electric motor versus a diesel engine. And the thing I always, try to point out too, is even that diesel still needs an electric motor in the starter to turn. And between the starter and the mesh gear and all of those things, you already have more points of failure just there than you would on the electric system. And this graph isn't like perfect, but just to give kind of an idea, I'll zoom in here a little bit. We can see all the parts on the diesel, a lot of which are consumable. So you're using them up. They need to be replaced annually or at certain hours. If the motor is in constant service, you're going to end up with, a lot more things going wrong, and they're being replaced and they're breaking down. On the electric, there's so many less moving parts. There's orders of complexity, less points of failure. And especially as, we get more time on the ocean, and the ocean obviously is a harsh environment, as we're all aware, but the electric stuff, as it gets refined down the road, is just going to be the end of propulsion system maintenances. Obviously with a generator, you still have those things. And I'll tell you this, on my boat, the generator represents about 95+% of my maintenance time compared to the electric system. I mean, it just doesn't even compare. And I, for that reason, as soon as I'm able, I hope to go pure electric. But for the way we use the boat now, it doesn't make a ton of sense. But down the road, if I can get rid of this generator, I'm going to be a happy guy. Going on to kind of the next part of the sort of complete system and the power management. And so you understand that, a lot of times when you're looking too at the electric stuff, the system costs look really expensive because you're maybe comparing it just to a diesel repower, where a lot of that diesel repower equipment, like the fuel tank or this, that, might already be in place. So you're not thinking of all the little pieces, but just kind of the block that you're replacing. But when you're doing the electric system, you're adding all this other stuff to the boat. But it's important to keep in mind that all of these parts come with added capacity. So it's not as if you're purchasing a direct one-to-one replacement for the diesel that just happens to have less range. You're getting a whole different system that's really set up to work in tandem with those, what I would consider the ethos of sailing much more, but you're getting something that has all this additional capacity. So we're going to go through this just real quick, just to kind of go and talk about some of these things, just to give you a little bit of an idea. So that their role, not just in the propulsion, but in kind of the full boat system, makes sense. In this one, the one here represents a DC generator. So it's a 48-volt generator, and it's outputting right on to number 4 here, which would be like the 48-volt bus. The batteries are on that bus, and that bus is also feeding the motor controllers, which are controlling the different electric motors. And then also going onto that bus is the solar system and the shore power system. And that bus is then feeding back into 5, which would be a charger inverter that's now feeding all the AC loads on the boat. And this also means too, from a boat's design standpoint of view, you get all kinds of new things that you can do, as far as like having much more capacity for AC, for alternating current on board, being able to, use other appliances that before you wouldn't have had the capacity to use, because this big battery bank will be able to invert and run air conditioners and tools and water makers and all that type of stuff without the generator needing to run, because it'll just be coming out of the battery's capacity. And then when the boat is sailing, these servo props here will be making the most amount of power possible for that boat speed and putting it back into the 48-volt bank that you can then use. And then, of course, too, the DC to DC converter is not obvious to me on this chart, but it's going to be able to take all this 48 volt and switch it over to 12 or 24, which also lets you, too, if you want to like have a certain 24-volt appliance, you can convert just for that appliance, and make a lot simpler circuits that way. It's not like you have to have the whole boat in 12 or 24 anymore. Also, there's a lot of large, service applications like windlasses, winches, line drivers, hydraulic power packs that can be powered at 48 volts and can be run at a lot smaller conductor, and they're all going to be a lot happier at 48. And so it gives you access to all of this capacity. And so now the house battery can become practically non-existent on some applications. Like I, for example, don't have a dedicated house battery on my boat. I convert in real time, and then I have a backup system where my generator start battery can be brought online as a 12-volt backup supply. But that basically gives me more room for the lithium batteries at 48 volts, and having everything at 48 volt where my solar's feeding in at 40, the generator's feeding at 40, hydrogen, and it gives you this big power reservoir that goes everywhere. And so instead of having some propane over here and some diesel over here and some solar coming into a different bank and no ability to hydrogen, I now have everything feeding into the one reservoir. I can always just add fuel if I get behind. But it's a great system for cruising, for living on, and it's really the capacity of that system is also the ability to get more systems onto a boat, to get more equipment onto a boat. So, for example, I'm on a 37-foot kind of old late 80s blue water race boat that we've converted into kind of a high performance live aboard cruiser. And I have hot water, air conditioning, electric, convection oven on a gimbal, induction cooktop, and big inverter things. I don't have a water maker, but I could if I found a little room for it somewhere. But I have all of this stuff that I would need a bigger boat that wouldn't sail as well in order to support all of these systems. And that bigger boat comes with, more cost of ownership, harder to handle, couldn't, pull down the sails myself in a gale. Like there's all kinds of things that I would need to, to do. And the real value of the system for me personally is that it lets me get everything I want on the boat that I want to handle and can afford to own. And so the increased cost of this system versus a diesel repower is a no-brainer for me. Or if you have, those applications, or if, when you start adding up all the value points between the ability to take advantage of the real estate on the boat, and when you're thinking of it from a design standpoint, especially for like a charter boat or something, by taking in all the design paradigms of the electric propulsion system, like for example, these servo prop motor heads here are super low. They can go under quarter berths. They can go under, in a catamaran, they can go under the sole in the hulls. There's all kinds of places now where these different parts of the system can be decoupled from where they had to be attached to the shaft before. And now they can go where they ideally where you want them to be in the boat. You don't have to have this big monolithic steel block in the middle anymore. And so that means you can get more real estate and more equipment on board. And that alone justifies the value, not to mention the fact that everything you're buying in battery cost is reserve capacity for everything. The generator is a generator, but it's also a much better generator because it's working in concert with the 48-volt battery bank. So I'm hoping I'm making good sense. And if you have more questions with more details, I look forward to answering them later. When we're getting in, I got to keep moving though. When we're getting into the Oceanvolt product and what we're offering, a big part is the things I described earlier with the integration with the 48-volt power backbone is kind of the core to our system. But a big other thing is that all the stuff in our system is talking together. So the batteries are talking to the BMS is then talking to the network's talking to the throttle, talking to the screen, talking to the motor controller, then talking to the power management system, that's talking to the inverter charger, that's talking to the solar power, to the DC to DC converter, to a smart shunt to monitor individual consumers. And then that's all talking back to us through the remote support and service interface. And so what this basically means is for your use, you have access to all kinds of great data as far as where the power is going and where it's coming from. Also, everything on the boat is chatting back to us. So if there's a problem, almost everything can be diagnosed remotely or with the data that's available on the boat. There's so few moving parts to break down that almost everything now is electric and monitored by software. And that can be a little bit, not everyone's a huge fan of that when they're first getting into it, but urge everyone to keep an open mind because the advantages are where these boats go anywhere in the world, as long as it can be connected to Wi-Fi, we can see everything. We can see the batteries, we can see all of that stuff. And we know, if you're having a fault, if this thing or that thing's happening, we can send the part or make the correction. Also, as new updates come, things like the servo prop will be increasing in its efficiency as it, learns better logic for finding the ideal blade angle for every condition. And then there'll be other new features and things that'll be able to be added on. And so that's a big part of kind of the basic architecture that Oceanvolt sort of built their system on, is being able to gather that information and communicate back to the system, either to make those fixes or to upgrade it down the road. And, the advantages of that are immense, especially when you need it. And, that's one thing that hopefully you don't. Hopefully with the Oceanvolt system, everything's working well. However, for those of us who've spent a lot of time on the ocean, I think we've learned that that's not always the case. And it's nice to have this backup that can reach out anywhere in the world. I talked about this stuff a little bit, so I won't spend too much time on it, but these are things too that I hope later on we can do more in-depth webinars on some of these subjects, maybe with people who are a little bit further down the planning road and are looking for some more kind of, design ideas, new paradigms, ways to think about stuff. And then ideally down the road too, as the community of electric propulsion, electric boaters grow, we can share these ideas and have really open discussions. I know there's obviously different competitors in the marketplace and all that type of stuff, but at least from my point of view and from the point of view of other folks that I talk about in our organization, it's really about the electric revolution on the water, and the free sharing of ideas for how we can do things better, I think, is a huge part of that. And so I'm never precious with ideas about these types of things. And so if people, if you're at that point where you're really wanting to move ahead with this, don't hesitate to ask and get some ideas on ways that these things can be done. And of course, in doing that, I hope to learn from y'all as well. It is a new addition to the marine world, and I think it's exciting, and there's a lot for all of us to share with each other. But this right here is really what the electric stuff is about. I mean, all the other things are great, but the fact that it really works in concert with sailing, and there's nothing wrong with electric powerboats either. But I'm a sailor first of all, and then electric propulsion enthusiast second. And this is really where the electric makes sense. It gives you so much better sailing experience, freedom of design, and ability to build the right boat for you in the right size. Because the other problem too is, as we know from this yacht game, right? There's a really nice place we all hope to end up where we're happy with the boat we have and we don't need a bigger one. And I see electric as being the way to get most people there. All right, so a couple things to consider as you're looking for a boat, either a new boat or a boat to refit, or you have a boat that you love, but it needs a repower and you've decided that you're ready to go with it. So we're going to look at sailboats. And again, there's other companies that offer other things. Oceanvolt, we have a sweet spot, and that's between 30 and 60 feet. And then in motorboats, semi-planing hulls, this is a Q yacht behind here. It looks like in Helsinki Harbor. And it's a Finnish-built electric boat, cool to check out. It's called a Q yacht. But it's a good example of kind of a design integration with Oceanvolt, working with the boat builder, kind of coming up with the right design. So a couple of things to consider. You have your sail drives, your shaft drives, and your pods. On my boat, I switched it when I switched to electric from a shaft drive to a sail drive. A lot of reasons. One, I wanted the servo prop. But also, when you're doing electrics, efficiency matters a lot more. You can't just throw extra fuel at it and not know where you're losing power. It's a more tightly run game. And so, the sail drive is just almost always going to have a better blade presentation as far as the propeller shaft, being off of the horizontal plane. And it gives you more options as far as where you can place it. There's going to be less drag as far as, like, especially in regen, the cutlass bearing doesn't float the straight shaft until you reach a certain RPMs based on shaft diameter. And so there's a lot of little factors to consider like that, that make straight shafts too a little bit harder to predict the actual real world application of how they're going to perform in propulsion and regen. So sail drives are just a little bit more of a known factor, and they have some other advantages, being you don't have a shaft field to leak anymore and other stuff like that. So figuring out what you want to do with those, and there are manufacturers who make pod drives too. People have specific questions about those. I'm not an expert on them, other than that I've replaced a couple with sail drives over the years. So they've had some issues, but that doesn't mean that they can't be done right. But at any rate, and then to figure out how are you using the boat? Because this is a really important consideration. A lot of folks may have aspirations of taking the boat all around the world, but they may only be doing weekend and day sailing and stuff, and they don't need maybe as big capacity system as they might want down the road. Other people know exactly what they're doing with it. They know what they want in range. There's other boats that might be on a lake or in a harbor or like a yacht club tender, and it has a very well-known theater of operation, and its range and charge times can be very well predicted. but you definitely want to go through that depending on how the boat's being used and come up with kind of initial power management schema. And then once the boat is in operation, those schema need to be revisited, improved based on real world operations. And, there's a good to leave a little bit of room in the design and in the budget for, adding batteries if needed and other things like that when you find out like how it's actually performing. But that's a really important part of the planning process, is coming up with those numbers and really having a good sense on what you need the boat to do. The next thing is coming up with the installation plan. And this is something that, on a new boat, you'll need to do with the designers and the builders input on a, depending on how the boat's being used. On a used boat, you can have it done by the installer. On bigger stuff, you're definitely going to want some input from a naval architect and things like that. But figuring out where the stuff can go in the boat, how it's going to be distributed in the boat, all of those things are really crucial, because there's certain types of batteries that have to be on like a certain length cable. So you can't have them spread out all over the boat. There's other batteries that you can spread out all over the boat and wire them in that way. Of course, obviously need to be wired in correctly. But figuring out all of those types of things, making sure you're making accommodations for some air circulation, like around the batteries and stuff, not required by battery chemistry in the lithium. They're not off gassing, but when they're set up for basically what's their temperature disbursement, they're going to want a little bit of space around them to move. You don't want like a big monolithic block where all these batteries are packed in right up next to each other, because the ones in the middle will end up with a different temperature profile than the ones on the outsides, which will affect their resistance, which will affect their charge and discharge, and over time will affect the battery bank's health as a whole. So there's a lot of little considerations. They're nothing crazy. They're nothing that, outlandish, but you just need to consider them. And then when you're thinking of a pure electric boat, you need to really get into the details. You need to think about how much solar you're having coming in. You need to think about solar shading, solar coefficients for where the boat is being used. Like what can be expected in this location for 100 watts? How many watt hours is that putting away a day? You'll find it's a lot less than you may think. And, those things need to be fully considered. And then stuff like, what's the refrigerator going to use? What's the freezer going to use in power? All those types of things. If you're going pure electric, all that needs to be done correctly, or the boat will lose power and be dead, or have to go on to shore power. And that's really what we're trying to avoid. So proper planning, et cetera, the rest. But basically, yeah, that's a big part of it. But, the nice thing is once that engine comes out and all the other stuff comes out, you usually have a nice space there. Like, for example, I put my generator there. And then back where the Cutlass bearing strut shaft was is where the sail drive is now. So the propeller blades are like in the same place. So thinking about stuff like that makes a big difference. And maybe too, we'll see, I can show you some of this stuff. But what we're going to do is kind of do a little quick recap. Obviously no exhaust, you may have noticed that I didn't spend a lot of time talking about that in this discussion. I think it goes without saying. The whole idea of it really making a big difference in the grand scheme of things is, dubious. However, the feeling of being on a completely self-sustaining boat, we did kind of the experiment last year of doing about, must have been almost 8 weeks in the Bahamas on pure electric. It didn't go perfectly. We had to take on some shore power from time to time, but it was, at least for me, a very rewarding experience to be able to use the boat, making its own power from the sun, making its own power while sailing. And it added a lot of value to the experience, and it makes you a better sailor. You get rewarded for sailing well in watts back into the boat. And so the whole exhaust thing and stuff is, I don't know, it can be a silly political issue sometimes too, that I think make people think that this is like a tribal thing, when for me, it certainly isn't. It's entirely about the beauty of efficiency, being self-sustaining, all for its own sake. I mean, it's really fantastic. It doesn't need to be a big, ecological debate or anything. It's really great. It's not really to do with what side of anything you fall on. when it comes to like the vibrations and the noise, it's hard to quantify this. It's hard to describe it. It's hard to say like what it isn't, but it is so nice to be able to motor completely quietly, pull in and out of ports without any vibrations, without any noise, especially at low speeds. You don't even know it's on. And it's just fantastic. I touched on this earlier with the more living space. But for me, this entirely justifies the value. When you're thinking of a new boat build, you're thinking of the value of the space on that boat for tech space and for living space. A properly designed and leveraged electric propulsion or hybrid system more than pays for itself in potential weight reduction, if that's what you're trying to design for, or in capacity on board for, house service, hotel loads, and propulsion as well. And then that goes into the complete power management. You're not managing all of these separate systems anymore. You don't have to like turn the generator on to run the water maker or blah, 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 blah. It's a single reservoir. As that reservoir goes down, it'll auto start the generator in a hybrid system. So you can prioritize too, if you want the generator running, between 11 and 2 p.m. every day, you can make the generator start more proactive during that time so that it's not starting up at night or in the evenings and other things like that, that really, there again, you got to experience it to really appreciate it. But it is a new paradigm of power management that it's, once you go this way, you'll never go back to running an AC generator in real time. It'll seem quite boorish. And then easy to use and maintain. Ultimately, I think this is actually hurting market acceptance. This is my own theory, so I'm speaking for myself here. But it seems to me a lot of boatyards in discussions have been kind of saying, hey, we make a lot of our money off of winterizing things and off of bad fuel and cleaning carburetors and all of these consumables that come from the diesel. And I think the diesel manufacturers know that too, and they are willing to sell their initial engine block cheap, knowing that they have a good 20 to 30 year consumable market there where they'll buy that engine over again a couple times in service and maintenance. And so the idea of the electric propulsion, where they're coming, like 15 minutes of annual maintenance, changing a zinc, changing the sail drive oil, or greasing a thrust bearing, and that's it for maintenance. I think a lot of these boat yards that would otherwise be excited about some new business venture are really concerned maybe where their profit margin will come from in the future. So that'll definitely be something that'll need to be addressed in some way down the road, I think, for a lot of people who we really need, especially in the US market. There's a ton of boats that need to be refitted or should be refitted. They got a lot of life left in them, but they could get a whole new second life with an electric system. But people have a hard time finding folks to do the work because they either have enough to do, they don't want to try something new, but they're also like, well, if it's an electric, when am I going to touch it again? So anyways, that's about it. And we have some time now for questions. I hope you guys, if you haven't been asking questions in the chat, I haven't been seeing it. So we're going to take some time now to address some of those that they'll send to me. And then I think we're going to keep folks on mute, but maybe at the end we'll have a little bit more time where some people want to stick around and we can try to chat. I don't know if that'll work. So we'll see. We'll kind of play it by ear. All right. So we got one about catastrophic failure and a rope cutter. So a couple things to keep in mind. I have done a lot of miles on my boat and I have caught some lobster pots. There's a ton of them down in the Keys. I don't know if you guys have sailed down there. It's like almost impossible to go around at night without bumping into one. Basically, what happened was it got picked up and the motor hit a stall point because the electric motor can be pretty closely monitored. And if it goes into a stall point, it goes into something called LOS, if the stall is there, which is loss something strategy. I want to say loss avoidance, but those acronyms not right. But anyways, it basically goes into like slow speed mode. But the nice thing is wasn't even wrapped up. It had about once around it. As soon as the blades felt the rope over the torque they should have been feeling in the water, they hit the stall air. I had to go swimming to get it off because I wasn't sure. I didn't want to try to spin it off and make it worse, but it came right off. It wasn't even wrapped up. I didn't need a knife or anything. I mean, just one hand, it was off. And then the other one, I just cut the rope. It was at night, and then it fell off while we were sailing. So I assume it wasn't wrapped either. That one was in the Delaware. It was in the winter in the Delaware. I wasn't hoping to swim, but it came off nicely. And so I'm not saying they're not necessary anymore, but there would be other considerations. Like, would the rope cutter, that diesel spinning with a ton of internal momentum and other things like that, the electric system is much lighter and it's much closely monitored electronically. So ideally, and this may take some more refining over time, but ideally rope wraps will be a thing of the past. The system will sense that there's something there and it'll stop turning. It still may need to be removed, but ideally too, in the future, we may be able to have something like a rope unwrap setting that's like that LOS, where it lets you use really low torque and low RPMs to kind of move the thing off without having to get in the water. But as far as putting them on a straight shaft, they can be put on a straight shaft. And if they're not cutting through the ropes, maybe some programming could be made to increase that stall point. Currently, the way our sail drives are set up on the servo prop and on the traditional sail drive, there isn't really room there for a rope cutter. So it's definitely a consideration. I'm not saying it's entirely solved, but in my experience, the electric system has been great for that. All right, on my boat, that's what size battery I have on my boat. So on my boat, I have a 14.5 kilowatt hour battery bank that is in lithium. It's a valence modules, 24 volt modules. And those are the ones, they are a little bit heavier, but they work better in a hybrid application because that being heavier also means that they're less susceptible to thermal loading from heating up and down from cycling. So when you get into the lighter batteries, you have to go into a bigger bank overall. So you end up with more capacity in the battery bank, but to cover the potential of the system, especially the potential charge of a DC generator, you need to go with a bigger bank. So this bank isn't as large as I would like. It probably, we're talking about like in range terms, at about 5 knots in flat water, I have about 6 hours of range. If I slow down to 4, it goes up to probably, well, it depends on what's coming in from the sun, but not counting that, it probably goes up to about 12 to 15 hours, depending on, again, a little bit of headwind or something though will destroy that at the lower speeds. And then on the top end, I can, push it up to about 7 knots, but at 7 knots on these batteries, I have like an hour and a half of range, if that makes sense. So, the 30 plus miles versus almost 10 at full speed, I'm rarely going on the top end of my speed. On the generator, I have a 6 kilowatt generator. And so that 6 kilowatt generator, if I'm running on 6 kilowatts, that puts me at about 6 knots. And so when you're putting together the boat plan and you're looking at those drag curves for what the boat's using in watts at different speeds, you want to kind of think of it in terms of like, what's the boat's maximum speed, which would be the potential. So I actually have a 15 kilowatt in here, which is overkill. So I have it programmed down to closer to like 6.5 because I don't need that 7 knots of speed and it just kills my range to do it. So I'm, at about 6 knots on the top of the throttle throw. And then that's what the generator outputs. Well, it's a 6 kilowatt generator. I've turned it down a little bit because it was making some black smoke. So it's at about 5.5 kilowatts in real time for the output. So another thing too to think about that is at 5 knots, I'm running the generator about 60% of the time because I'm using 2.7 to 3 kilowatts. And then at full speed, I'm running the generator in real time and putting a little bit into the batteries, but I'm taking it out in house stuff too. The other cool thing, I didn't really go into this that much in the design thing, but in thinking of the hybrid system, the generator is no longer attached to the boat via the drive shaft. So it's isolated on isolation feet, and then it's inside a pod on another set of isolation feet. So you basically, it's a totally different experience. When that generator is running, you hardly even know it's on, and you can put on like a thing that splits it. So anyways, I went into the question there a little bit more for the details there, but the lithium batteries, it's just important to remember there's different chemistries in lithium, and they're going to have different principles as far as how big a bank you need and what application and where they can go in the boat too. The ones I'm using, I can put them in different places. Whereas if I was using like the Cleantron batteries, I would need to find a place where they could all be close enough to their connection box to hook in. So there's definitely a lot of things to consider when you're thinking about batteries. So a question about hydrofoil boats in Oceanvolt, that's a great question. I think for those of us who've been working in this sphere for a while, we're kind of realizing that the electric power boats are probably going to need to fly, or we're going to need some major breakthroughs in battery technology. So short answer is nothing to talk about right now from Oceanvolt's side, but I think as far as where the industry is going, foiling boats have a lot of advantages. The technology will get cheaper as it gets more ubiquitous. They can make software that can control the flight, and then it can be scaled up for all future versions. So there's a lot of things about foiling boats that are really expensive now that'll come down in price. And for comfort reasons and stuff, they're fantastic. For wake reasons, for all kinds of things, they're great. So I really hope that's where stuff goes, but no new news right now. So here's a question about regeneration with loss of speed. So yeah, there is. It's not perfect. There's things that can knock the boat out of regen, like turbulence, big waves, hitting a wave. The Oceanvolt system will attempt to start the regen when that happens. But it's certainly an issue where the software will need some more refining. I wouldn't say that it's perfect now, but the nice thing is about the Oceanvolt platform is the hardware, especially in the servo prop, is designed to be very dynamic. So as we get better signals from other places on the boat, as far as like water speed, wind direction, sea state, stuff like that, the servo prop will be able to make more intelligent decisions about what it has its blade angles at down the road. And so that's something that isn't perfect. Like for example, I don't usually regen much if the sea state's really bad, because you don't get a lot. You can get some when you're surfing. So if I'm going downwind, then I will. But if I'm going upwind, I'm going to be defeating my apparent wind loop a little bit and requiring a little bit more rig pressure for the same speed. So there's certain points of sail where regen, and certain sea states where regen isn't that good. There's other times, especially when we were down in the Bahamas last year, going pure electric, for example, pulling in to like Governor's Harbor and Eleuthera or Rock Sound, where we'd been using power up in our living, but we were on the lee of Eleuthera, and so the water was super flat, but we had a great sea breeze, and we did laps for a couple hours because we were able to make a ton of regen in flat water, beam reaches, and it was great. So it'll be getting better and better and better for the adverse situations, and right now it is a consideration to think about: is what seas are you going to be in, and what will they be able to do. We have another question here about network specialists to deal with individual projects on each boat, and I'll say that's an issue. It's an issue in the market right now where there's just not a lot of people who have expertise in it. If you're coming up, in the U.S. market, I use my company as kind of a stopgap, meaning we try to find a local installer, boat yard to work with on a project. But if we can't find one, I try to offer kind of a last resort for an installation. And that can kind of come to design too. Ideally, we want to grow the market knowledge about the new paradigms of electric propulsion and how to properly install them. But until then, we definitely need more reference boats out there too to help teach people these lessons. And there's no better sales pitch than taking an electric boat out for a sail. So if somebody is, raring to go on a project and you want it done, you can contact me directly. You can contact Oceanvolt sales at Oceanvolt as well, especially outside of the U.S., which is kind of outside of my purview. I'm kind of just the Caribbean and the U.S. I try to help with South America, but don't do a very good job. But basically, there are builders, there are network specialists, there are agents. They're in Germany and France in South Africa. And so, there's Netherlands, there's people we can send you to in England, Norway. We definitely have partners out there, but they may not necessarily be right in your town at this point. But if there's someone too, and you're ready for a project, and there's someone who you like, who you've worked with in the past, we will do everything we can to support them in the design process and in the installation, because obviously we want all the systems to be as successful as possible, and that's a huge part of the system success, is getting it installed right and having it designed right. So someone's asking a question about the integral setup, doing a diesel on one side with the 48 volt and an electric system on the other. I see no problem with that. There is some advantages in my mind of doing the hybrid with the 48 volt generator. The number one being is that generator is going to be a lot more efficient than the larger displacement diesel will be. It has a lot more, cylinder space than it needs to run that integral thing dedicated when it's in like generator mode, when the boat isn't moving. And you get, one of the great things, another just story from my own experience. Last year when we were heading back up north, we were coming up the Chesapeake right around the time Maryland had just opened up, and we needed fuel because we hadn't been able to get fuel all the way up the Chesapeake for the generator. So we refueled in a marina that I won't call out here on the Sassafras River that has a big seawall, and they gave us really bad fuel. And literally we were just into the C&D canal when the generator stopped and both fuel filters were totally clogged. I mean, we'd just been pumping white goo. But I had the electric propulsion and I had enough reserve. I was running the generator proactively. I was kind of nervous about the fuel being bad. So I'd been running the generator as soon as we fueled up before we needed it. And so we were able to get all the way through the canal into the Delaware and then start sailing and regenning. And then, thinking of, we were able to get all the filters cleaned out before we got around Cape May. But, we basically had a time where we were in a canal, high traffic area, Maryland had just opened. Everyone who had a boat was out on their boat. And we would have been dead in the water if we'd been relying on diesel. And so I know it was the electric. It's kind of like, oh, we're taking this step into the brave unknown. But properly set up, properly installed, it's just so much more reliable. And so the hybrid system gives you kind of that extra redundancy. And so on a catamaran, you can still get around fine, in most situations with just the one drive. But something else I hadn't mentioned too, especially when it comes to like servo props, we're putting them more in dual drive applications. But another great thing about the hydrogen is it gives you a really good droguing effect, especially in like a surfing situation. It helps keep the bows down, and it, gives you a little bit more rear end stability. And on a close reach, on a dual drive system, it lets you regen to weather, where you're able to basically get free power for what would have been helm drag. And that's really cool. And so you miss out on that when you do the one electric and the one diesel. So it's certainly a doable arrangement, but it's not necessarily ideal in my mind, but it's doable. So safety standards question is a good question. A lot of that's going to depend on where the boat is being used. So in the States, I'm an ABYC marine electrician, an MEA certified tech, and MEI certified tech. There's nothing in the Oceanvolt system that goes outside of those standards. There's E30, which is the ABYC standard that pertains specifically to electric propulsion. And I think it also covers lithium batteries, although that may be in a separate standard. Forgive me for not being able to quote it by verse. But basically, it's all covered in the ABYC standards. When it goes to like European certification, one of the reasons Oceanvolt is on the 48 volt nominal architecture for the power is to make sure that any European marine electrician can work on it. And so it all, again, it's really not any more complicated than a bow thruster or a windlass. or a NEMA, with a CAN NEMA network on it. But it's just different, and it's a little intimidating to people who haven't done it before. But I can tell you from someone who's installed a lot of these, it's simpler than a lot of electric systems on a boat. You have to make proper considerations. It has to be done right. You have to think of ampacity. You have to think of the wire bundles. There are bad habits people have gotten into in the marine electrician because they're not working with huge currents for sustained periods of time. So you do kind of have to go back to basics a little bit and go, okay, we're just going to make sure we're like really doing it right, getting our wire sizes right, maybe oversized a little bit if the boat's design parameters aren't all about cutting weight. And just make sure we're kind of covering our bases by overbuilding a little bit. And then checking on things too, as time goes on, checking on those terminal connectors on the buses and stuff like that, making sure they haven't loosened up, they haven't gotten corroded. But if everything's in there and it's installed right, there's really not too much to worry about. Protecting the batteries is really important. And that's one reason too why the batteries that we would recommend and would sell to our customers are going to be a lot more expensive than batteries that they can find on the back corners of the internet and eBay. But there's a reason for that, and we're persnickety. Like, we won't sell a system to an unproven battery bank, because safety is super important, obviously, and there are potentially bad actors in the battery world that are known brands. They're not really telling you what's happening inside of the battery for protection and stuff. So I would just, tell everyone, when it comes to safety and things, the batteries are a concern, not if they're done properly, but if you're getting like these kind of black box batteries that you don't really know what's going on in them. A lot of those are going to be like seconds from the automotive world that have been rejected and they're getting repackaged and stuff. So really try to avoid fly-by-night batteries. Well, I think that's the end of our time. If people have more burning questions and stuff, please reach out to me. I'll go back to the slide that has my contact info on it too. I am working on a refit here in Miami, but I can take phone calls / WhatsApp calls if you're overseas. I'm not great at responding to emails quickly. I apologize about that. If you want to get a hold of me, the best thing to do is call or email sales@Oceanvolt. All right. Thanks so much for coming.